Welcome to Gyan Niketan YouTube channel. I am Dr. Harendra Kumar Sinha. Today I shall discuss the continuity of a function at a point. Continuity of a function, we firstly suppose fx be a real function. Fx be a real function. At a point, at a real point x is equal to a. What is the meaning of a real function? Meaning thereby, the domain and codomain of this function fx will be the subset of the set of real number. A real point x is equal to a, meaning thereby that a is the real number. That is, I am going to describe about the continuity of the function fx at the point x is equal to a. Now, let me describe the definition of it. Firstly, the left hand limit. That is equal to limit of the function fx, x approaches to a minus, that is limit x tends to 0 f a minus h. This limit should exist. Right hand limit, that is limit of the function fx, x approaches to a plus, that is equal to limit x tends to 0 f a plus h. X tends to a minus, meaning thereby x will approaching to a from the value smaller than a towards a, and x approaches to a plus means x will approach towards a from the value greater than a towards a, and the functional value and the value of the function f. If the three be equal, then the function is said to be continuous at x is equal to a. So if this limit of the function fx, x approaches to a minus is equal to limit x tends to a plus fx is equal to fa, then the function fx is continuous at x is equal to a. If any one of the three not be equal, then the function will be not continuous, that is the discontinuous at that point. So for the sake of the continuity, the limit of the function should exist, and then that must be equal to the value of the function. So in short, we can write for the continuity that if limit of the function fx, x approaches to a is equal to fa, then the function is said to be continuous. Let me illustrate this with the help of an example. I am writing one example here, and I shall show you that how the function is continuous or not continuous at that particular point. I am taking one example. Let fx is equal to, fx be a real function, defined as fx is equal to 2x square plus 1 if x is less than or equal to 1, and this is 4x minus 1 if x is greater than 1, and my objective is to verify the continuity of the function at x is equal to 1. So we compare it from the very first definition that here fx is given at x is equal to a. This is the real function and this is the real point. Means the continuity is to be verified at x is equal to 1. So firstly I shall find out the left hand limit, then right If the 3 comes equal, then we claim that the function is continuous at x is equal to 1. So, firstly, I find here the left hand limit. In short, I write LHL, left hand limit. That is limit h tends to 0, limit h tends to 0, f1 minus h is smaller than 1. 1 minus h is smaller than 1. Here, in place of x, we are having 1 minus h. Obviously, it is smaller than 1. We are subtracting a little bit from 1, so that will be smaller than 1. And for x smaller than 1, we are having the definition 2x square plus 1. So we write this is limit, it is 1 minus h whole square plus 1. Put here h is equal to 0, so it will be equal to 3. 2 into 1 plus 1, that is 3. And right hand limit, it is limit h tends to 0, f a plus h, that is the limit h tends to 0. You see here x is 1 plus h. Obviously it is greater than 1. As it is greater than 1, the second definition stands here. For x to be greater than 1, it is 4x minus 1. So we write 4 into 1 plus h minus 1. And putting here h is equal to 0, we have 4 minus 1, and that is equal to 3. So left hand limit is obtained, right hand limit is obtained, and then I shall find out the value of the function. That is I find out f1 at x is equal to 1. The definition is 2x square plus 1. So we write here it is 2 into 1 square plus 1, and that is equal to 3. Here all the 3 being equal, the function is continuous at the point specified, that is x is equal to 1. Here this limit h tends to 0, f1 minus h is equal to limit h tends to 0, f1 plus h is equal to f1. Therefore this fx is continuous at x is equal to 1. This is how we verify that the function is continuous at x is equal to at any particular point. We find out the left hand limit, we find out the right hand limit, and we find out the value of the function. If the 3 becomes equal, then we claim that the function is continuous at x at that particular point. Another example is, let fx is equal to kx square plus 2 if x is greater than or equal to x is less than or equal to 3, and it is 3x plus 1 if x is greater than 3, is continuous at x is equal to 3. Then find out the value of k. Then find out the value of k. Then find out k. We have to obtain the value of k. The function is already been given. The function is continuous at x is equal to 3. So what shall we do here? We find out the left hand limit, we find out the right hand limit, we find out the value of the function, we equate them, and from there we have the value of k. So firstly we obtain the left hand limit, that is limit h tends to 0, f3 minus h. Here in place of x I have 3 minus h, so it will be smaller than 3, and the definition kx square plus 2 will be utilized. So here we write limit h tends to 0, It is k x means 3 minus h whole square and plus 2. We put here h is equal to 0, so it is 9k plus 2. So it is 9k plus 2. We find out the right hand limit. The right hand limit, that is limit x tends to 0 f 3 plus h. 3 plus h is more than 3, so this definition will be there. It is limit x tends to 0 3 times 3 plus h plus 1, so it is 9. Putting h is equal to 0 here, putting h is equal to 0 here, it will be 9 plus 1, that is 10. That is 10. So since the function is continuous, the 2 must be equal. Therefore, we have 9k plus 2 is equal to 10, or the value of k is equal to 8 over 9. And this was to obtain. Here, it is already been given the function to be continuous. Therefore, it will be sufficient to equate the two. We can also find out the value of f3. f3 will be exactly 9k plus 2. So equating them all, we have the value of k is equal to 8 by 9. This much for today, and in the next video we shall meet discussing something more related to it. Thank you.